For number 24, we are solving the equation 9 to the 2x minus 5 equals 27 to the x minus 2. So the question is, how can we get the same base on both sides of the equal sign by changing the 9 and the 27? Well, both 9 and 27 have a 3 in common. 9 is the same as 3 squared, and 27 is the same as 3 to the third. And now we can use our rule that tells us when we raise an exponent to another exponent, we multiply. So we're going to distribute this 2 to give us 3 to the 4x minus 10. And we're going to distribute the 3 to get 3 to the 3x minus 6. And now because both sides of the equation have that base 3 in common, we can set the exponents equal to one another. So 4x minus 10 equals 3x minus 6. And then to solve for x, we just need to get the x's on the same side and get the constants on the same side, and we end up with x equals 4. Number 26, we're given 4 to the negative x equals 16. So how can we make a 16 look like a 4 using exponents? Well, 16 is the same as 4 squared. So now because we have the same base of 4 on both sides of the equation, we can drop those bases and just set the exponents equal. So negative x is equal to 2, or dividing both sides by negative 1, x is equal to negative 2. Number 27, 2 to the x equals 1/2 to the 13th. So 1/2, we can get that 2 out of the denominator by raising it to the negative 1. So 1/2 is the same as 2 to the negative 1. And then we can multiply our exponents on the right side to give us 2 to the negative 13. And now because we see that base of 2 in common on both sides, we can drop the bases and just set the exponents equal. And that gives us x equals negative 13. Number 28, we have 2 to the x plus 1 equals 64 to the third. So 64 is the same as 2 to the 6th. And then we can multiply the exponents on the right side to get 2 to the 18th. And then we can set our exponents equal. X plus 1 is equal to 18, and then subtracting 1 from both sides tells us that x is equal to 17. Number 33, we're given 7 to the x squared plus 3x equals 1/49. So I'm going to start by getting that 49 out of the denominator by raising it to the negative 1. And then 49 is the same as 7 squared. And then 7 squared to the negative 1, multiplying those exponents together, gives me 7 to the negative 2. And now because I have a base of 7 on both sides, I can set the exponents equal to one another. X squared plus 3x equals negative 2. Now here we're solving a quadratic equation. We know that because of the exponent of 2 on the x. So to do that, we're going to set it equal to 0. We're going to add that 2 to both sides and then see if we can factor this thing, which in this case we would need two numbers that multiply to positive 2, add to positive 3, which would be a positive 2 and a positive 1. And then setting both of those factors equal to 0 and solving would give us x equals -2 and x equals -1 as our solutions. Number 37, we have 6 to the 2x equals 36 to the 2x minus 3. So the 36 on the right side is the same as 6 squared. And then we can distribute the 2, multiplying the exponents on the right side, to get 6 to the 4x minus 6. And now since we have that same base of 6 on both sides, we can set the exponents equal. And then to solve for x, we can subtract 4x from both sides and divide both sides by -2. And that gives us x is equal to +3.